Welcome to Math YouTube channel. In this class, I am explaining about functions. What is meant by function? Function is nothing but a relation. What is a relation? Relation is nothing but mapping from one set to another set, or mapping from elements in one set to the elements in other set. That's all. Okay. So here, what is function? Simply, function is nothing but a mapping. Okay. Take two sets, A and B. There are two sets. Those are A and B. In these two sets, those two sets are non-empty sets. This is very important point which you have to observe. Two sets are non-empty means definitely the two sets containing elements. Those are non-empty sets. Those are non-empty sets. That means something, at least one element containing each set. At least more than one or one. That is, two are non-empty sets. Those are A and B. Okay, first point, that one. Next one is, let F be a relation from A to B. Relation is nothing but mapping. The elements in set A to elements in set B. That's all. So that is mapping, that is relation. That is F. That is F. For each element in A belongs to A. This is set A. The element set A is A. So for each element, please observe carefully. For each element means each and every element in A should be taken under consideration in mapping from A to B. That is important point which you have to observe. Okay. So each element, for each element in A, set A, there exists unique element in B. Unique element means one element. There exists unique element in B, not more than one element. Unique element means one element, such that AB belongs to F. AB means A belongs to A, B belongs to B. That is F. Those two elements, that pair containing F, mapping, then F is called a function or a mapping from A to B. So, please listen carefully here. Two sets are there. Those two are non-empty sets. And for each, there is F is a relation from A to B. F is a relation from A to B. F is a relation from A to B. A and B are non-empty sets. And for each element in A, means each and every element in A, in set A, there is this unique element in B, such that A belongs to F. So, for each element in A, there exists at least one relation with the unique element in B. Unique element, not two elements, only one element. So, for each element in A, there is relation with, mapping with unique element in B. Then F is called a function. That is from A to B. Determined by F from A to B. Here, the elements in set A is called domain, and element set B is called codomain or range. So, element set A is called domain, and element set B is called codomain or range. Okay? Take an example. Here, A equals to 1, 2, 3, 4. 4 elements are there. That is in set A. B equals to 1, 8, 27, 64, 125. That is 5 elements are there in set B. There is a relation. What is the relation? Relation equals to f of x is equal to x cube. Left side is belongs to A and right side is belongs to B, set B. Okay. Now see here, f of 1 equals to 1 cube equals to 1. F of 2 is equal to 2 cube equals to 8. F of 3 cube equals to 27. F of 4 cube is equal to 64. Only 4 elements are there. F of 4 is there. Okay. Now here 125 is there, but no element in A for mapping from A to B. We want to take only 4 elements. That is important point you should observe. Leave it about this. Don't worry about 125. But we will have only 4 elements. For each element in A, there is image in B. There is at least one image in B. For each element in A, there is image in B. So clearly, for each element in A, there is a image in B. That is important point. Image, object image means, for example, you can take the set A, take set B, 1, 2, 3, 4 elements are there, and 1, 8, 27, 64. 125 is there, but there is no mapping from A. 1 to 1, 2 to 8, 3 to 27, 4 to 64. Here this is object, this is image. This is object, this is image. This is domain, this is range. Okay? So A 1, 2, 3, 4, B 1, 8, 27, 64, but not 125. There is no pre-image for 125. There is no object for 125. So here domain equals to D equals to 1, 2, 3, 4. Range R equals to 1, 8, 27, 64. That's all. This is a function from A to B. Function from A to B. This is very important point to observe here. Limit about 125. We will have object and image. There is at least for each element in A. First condition is 2 non-empty sets. Okay, first condition over. For each element in A, there is a pre-image in. For each element in A, there is image in B. For each element, take 1, 2, 3, 4. Yes, there is image in B. So this is a function. This is a function. This is function 1, 1. That is f equals to 1, 1, 2, 8, 3, 27, 4, 64. This is a function. This is domain, this is range. This is about function. Okay. Take another example. Take a set A. Take another set B. These two are non-empty sets. Okay. Some 3, 7, 8, 9. Some 23, 4, 5, 67, 89. Okay, something. Mapping. Here This is domain, this is range. But take this one, 3789. 3789 is there. 23, 45, 67, 89 is there. There is a mapping F. But condition is, for each element in A, there is image in B. Okay, but 3 will have 23 as image, 7 will have no image, 8 will have 2 images 45, 67, 9 will have 2 images 45 and 89, but there is no image for B. That is why this is not a function. F is not a function. This is very important point you have to observe. Okay? So, for each element in A, there is image in B. At that time only that is called a function. But this is not a function. Okay? This is about difference between function and not a function. Okay, dear friends? Please observe this. For each element in A, there is image in B. At that time only you can call it as a mapping from A to B. That is a function. But this is not a function. Okay? Okay, dear friends? Thanks for watching Math Web YouTube channel. If you like this video, please subscribe our YouTube channel Math Web and turn bell icons to get more information. Thank you.